Welcome to another video on the build of my Disca Porsche 911 GT3 by 201 slot cars, or 201 slot cars perhaps. Now, next step of the process is to get this pod installed on that chassis with its correct suspension. Now, what you're looking at here on the front row is all the scale auto springs. What we've got here are on the left are the short ones, and over here we've got the long ones. And these are scale auto suspension screws, sorry. These ones happen to be aluminium, and if I'm not mistaken, they list them on this dimension from the underside of the head, and that one is 9mm. I've also got the long one, which is I can't pick it up with bare fingers. That's the long one. This one's far more suited to use in cars that run slotted motor pods. If you think about it, on a slotted motor pod, this part here is about, where are we? That part is about 3mm deep, and likewise, so is that part there. So you end up running a screw through about 6mm before you even get opportunity to put a spring on there. Now this car's not like that, so this car can get away with the shorter ones, and it can function perfectly well on these shorter springs. Now, Scale Auto furnishes us with a soft, which is metallic, a medium, which is black, and a hard, which is gold. Gosh, don't want any magnetism in your screwdriver, do you? So you use ceramic tweezers instead. Now then, if you look at these two springs here, they're the long ones. They're black. They're supposed to be the same as one another. I don't know whether it's clear to you, but that one there is a lot shorter than that one there. Not at all impressed by those. Likewise, these soft ones, there's a smaller difference, but that one there is not as tall as that one there. And I think this speaks volumes of the quality of the coil springs that we get in the slot car industry. Basically, they're not very good. It's the same with most of the manufacturers. Now, the reason I've got the Scale Auto springs out here to show you is because these little plastic nuts, nylon nuts, I've got that little spring perch locator on the right hand side of that coil, and that's the perfect diameter to sit in a Scale Auto spring. So what my opinion on these springs is that these are too hard. The hard ones are too hard. If your car was 130 grams or so, maybe they might be the right springs. These ones here, the softs, they're too soft for a car of this type being about 80 grams, 80 to 90 grams. These are very, very soft. If your car was 60, 70 grams, maybe they'd be right. And what that leaves us with is the black ones. I'm not going to say they're the hot ticket, but of this range, they're the ones that seem to suit the cars best. So let's get rid of some of this. Now we've got that into place. So I said I was going to use these Scale Auto black springs, and I'm certainly going to use this short pair down here and opposite. I'm going to use one of these two, probably the shorter one, in the middle at the back there. And on here I've got something else to show you. Now these come from Thunder Slot, and they are suspension springs that aren't coil springs. They are pieces of sponge foam, black and very easy to lose. Now they come like that, and the hole in the middle is about 3mm. It's huge compared to a 2mm suspension spring. This is one that I've cut in half, and the reason I've cut that in half is because just there I don't have a lot of space for the nut, but I'm going to put an M3 nylon nut on top of there with a flange, just like this one. Again, I purchased these from AliExpress. There's 100 listings for these in a billion colours. So let's get the driver, start that on top of that thread, and I'm not using the typical screw that I've already showed you just here. I'm sorry, I'm off camera and probably, oh, I'm not actually. There we go. Just move to where I can hold it better. So we'll not crush that for now. I'll just bring that so that I know that that screws through the nylon part of the nut. And let's have a look, see if I can show you. Gosh, that's difficult to see. But yeah, it can rise. There's no looseness, but under load that can rise a tiny bit. Now we're going to go on to, oh, I've got a different screw in there because I'll show you why now. One of the most disappointing aspects of this car is that that hole, that recess there for the screw head is large. The screw head, I can't show it, yeah, the screw head will go in and it will move around, and I don't like that. So I went to the box and I found some brass screws of a different manufacturer. Don't know exactly what they are, but they are the same length. They might be slotted, they might be thunder slot. I'm not sure who else manufactures these, but I went to measure this diameter, and there seems to be some agreement on this diameter, but there doesn't seem to be any agreement on the neck, the plain neck, which is 176 in that case and 164, 165 in that case. So what we got, a 1/10 of a millimeter difference. I don't think that's going to make a huge difference between the performance of those screws, but the result is that when I stick one of these up through there like that, it comes out of here, and I don't know whether you can see it right now, but the hole in the motor pod is larger than 2 millimeters. I haven't feeler gauged it, so it might be 2.4 like some of the rest, but difficult to see. Change my light a little bit. What that results in is for the motor pod to be able to do this. There it is. It's moving left and right. And that's all to do with the fact that that head can wobble around inside that aperture, inside that recess, and that hole in the motor pod there is a tiny bit larger than I think it ought to be. Now, I've spoken to the manufacturer, designer, about this, and whether or not he changes it is up to him, but that's my feeling on the matter. Spring on, and then one of these 3D printed screws, nuts. Now, I have popped the screws into these nuts before so as to put the thread in there already, but I do have to tell you that I don't like flathead screws. And I've made this a tad tricky, haven't I, by leaving the tyres on. But trust me, I've done it a few times already. There we go. And it will go together like this. It needs to be able to, so that you can do it at the track. So I'm just going to thread that screw through until the end of the screw is flush with the top of the nut, like that. And you can see that the wing on the nut slides up and down, or can slide up and down in the slot in the motor pod. And there's the suspension in motion. Now, we've taken a spring like that long. Let's get a number for that. 4 millimeters nominally, and we've squashed it down to that long. How long is that? Three. Question is, did it get harder? Now think about that. What happens now? Let's say I screw this in some more. And now that screw pokes out the top of there by 1 millimetre. So in theory, we've now swashed that down to 2. Did it get harder? Well, the answer is, no, it didn't. All that happens as you screw these screws in and out is that the range of motion, i.e. how big this gap here can get, reduces or increases. But the spring does not get harder or softer. The reason for that is because of the design of the spring. The design of the spring is a constant radius coil with a fixed distance between the coils. And what the diameter, the thickness of the wire, which is actually the difference between the soft, the medium and the hard. The hard is made of thicker wire than this one, and the soft is thinner wire. So because of the design of the spring, that gives it a value, and what that value is, how that value is expressed, is how much weight it takes to move it a distance. So let's use grams and millimeters because I'm from the UK. Let's say it takes 15 grams to crush this a millimeter, and that's its defined specification. So you put 15 grams on it and it crushes 1 millimeter, and you put 15 grams on it and it crushes another millimeter, and that one disappeared. That could be a challenge to find. So we've defined the specification as 15 grams per millimeter. Every 15 grams crushes it another millimeter. It doesn't get harder. It now took 30 grams to crush 2 millimeters, and then the next millimeter will take another 15 grams. And that's why springs don't get harder just because they get crushed. So, and a final additional comment on spring design is that this 4 millimeter long spring is made of 1, 2, 3, 4, 5 coils. 1, 2, 3, 4, yeah, 5 coils. And this long spring, which may very well be made of the same thickness wire, is 1, 2, 3, 4, 5, 6, 7 perhaps. 1, 2, 3, 4, 5, 6, 7 coils. So we've got 2 additional coils, and that's what's making it longer. The gap between the coils is the same. And what does that do? Well, what that means is that 1 millimeter of compression, again, magnets, 1 millimeter of compression into this 7 coil spring will mean that that millimeter is absorbed 1/7 by each coil, whereas 1 millimeter of compression in this 5 coil spring means that each coil has taken 1/5 of that millimeter. And what that net result of that is that even though this black spring and this black spring are made of the same wire diameter, because there is a design difference, this one's actually softer than that one. That's because 1/5 of a millimeter absorbed by each coil in that case, and 1/7 of a millimeter absorbed by each coil in this case, means that this one bent less. And what this is a bar that's been wrapped round in circles, and you've bent that bar less than that bar when you've only absorbed the millimeter over 7 coils rather than over 5. So the one we lost, and yes, trust me, the room is a lot cleaner now. My litter bin's empty and everything on this table has moved. Still didn't turn up. It will. It's only one of the long ones, and we're only using one of them. Unfortunately for me, I've still got one of them. I'm going to pop it on just there. I've got both the short ones on the sides, and I'll show you. This is an easier way. I mean, we've got suspension now. We could run this like this without a spring in the back, but the problem that I was showing you before, this one, is very, very obvious, and I really need a screw in the back there to maintain that alignment. I'll resume when I've fitted that back spring. Okay, so I've got that back spring into place now. Important question I want answered is this improved? Well, I think it has marginally, but it's not gone, and that's rear wheel steering. Like I said, I don't want that. I want to try and eradicate it if I can. But now, this is the first opportunity I've got to assess what I've actually put together. Yeah, we haven't got the braid on the guide at the moment. This is actually very low. That should be a tiny bit higher. We might end up putting a guide shim in there. because the ground clearance in the centre of the car seems very low. We've clearly got ground clearance, but not much. And the ground clearance at the back, yeah, we've got plenty. And this is where the body shell applies its forces. What actually happens as that takes place? Can you see that rear spring acting, but these barely move? And this is why I spoke about the gold hard springs being too hard for cars like this. And that's because they just bend the chassis. They stay put, not move, and the chassis will bend. And I think that's already happening here, look. Between this point and this point back here, the chassis must be flexing a little bit because the diffuser's going up and down. Right, let's test that. Put the diffuser on the table. Is this on the table? Not quite, look. So it's easy to bow the chassis, especially when you've got springs, one behind, another one in front, things like that. If you get the loads wrong on these springs, it's just a disaster. It'll just warp your chassis for you. Anyway, we've got suspension now. I haven't got these wound down far enough to limit the range of travel. What car has got a limited range of travel? I mean, what real car? Let's take, for example, a one-to-one rally car going down a bumpy track. Is it possible for them to hit the floor? Let's take our road cars. Is it possible to go over a humpback bridge and land and hit the ground? Well, yes, you can. That means that your car has got a full range of travel all the way from ride height to the ground. And so why should a slot car be any different? There's no point in actually limiting this that I can think of. That's a little bit of body roll. You can see it doing this. Different to how a slotted one does. It's the first car I've ever built with a pod in this style where there's only one spring at the front and back, and of course the slottits have got 6 on, haven't they? And they don't quite move the same way. Yeah, it's different. I don't know how it's going to change the way the car drives. Which is theoretically better? Well, I think this might be, but I mean, we'll see. Yeah, there's plenty of movement in those slots for those wings on those nuts. Yeah, we've got suspension. And what's left to do now is check that we've got the correct ride height underneath the motor. Remember, the regulations dictate that ride height is ground clearance is 1.8 mil, and what you can see along the front edge here is a range of little metal discs that I own that are actually motorcycle engine valve shims. They're all different thicknesses. Don't know whether you can read it, but etched on the top of these is 1.7, 1.75, 1.8, 1.85 and 1.9. Perfect range of measurement devices for this regulation set. Now, we'll take the 1.8. We'll stick it on the motor. The motor will hold on to that, and then now we'll see whether or not we've got that amount of ground clearance underneath the motor. And the way I always check for that is by listening. Tap, tap, tap. And then I do this. Can I hear scrape? Well, yes, I can. But I would say that's legal. And if I take that 1.8 off and switch it to 1.7, you'll see how obvious the difference is. Now, almost no scrapey. You can actually see the car bend to get that extra 1/10 of a millimetre down to the ground. So yeah, they're very, very useful. Again, purchased on AliExpress. Motorcycle engine valve shims is your search. Put those aside. Stick the 1.8 back on the motor. Put the car back on the deck. And have a look underneath. I can even get this like this and shine a torch from the opposite side and see whether or not there's clear light passing through between the shim and the plate. Several ways to check that. Now, bear in mind that right now we've got no braid in the guide, so that will come up a 1/3 of a millimetre, and even that will lower the diffuser, raise this centre section here, all the way through here, will raise by that amount. So right now, in here, we've probably got a ichrometer measurement of about, oh, hang on, we've got the shim on, haven't we? Don't think that's making a difference because that doesn't move, that stays there, only this moves. We've probably got 0.7 millimeters or something like that there, but that will come up because of the braid. I think we've got things right now so that we can go ahead and install a front axle, and for that I'll bring you to a new video. Didn't realise I could talk about springs and suspensions for as long as I have, and how they apply to slot cars, well, how they work in principle. But thanks for coming along. I hope you're enjoying this series. Share it with your friends, hit the like button, leave me a comment in the comments below if you think I'm wrong about anything or you've got anything to add to what I've said. I want to hear it. I want to learn from you, just how you can hopefully learn from me. See you in the next one. Thanks for watching. Bye.